Hey guys, welcome back everybody. So I'm just sorry, I was a little busy last 2 days, right? I was traveling from Bangalore to Delhi, right? And I'm gonna get got very badly fever right now. But anyways, right? So what we have discussed, let me start. Let me recap the last classes, right? If you guys remember that, we have discussed about the path manipulation of BGP protocol. If you remember that in the IGP routing protocol, we have a different ways to manipulate the path. If you go with the RIP protocol, we have a hop count and we have offset list to manipulate the path, right? If you go with the advanced label, you can do the summarization, and based on the summarization, also you can do the manipulation of the path. In a EIGRP protocol, if you guys remember that, we have seen how to change the delay and bandwidth. At the same time, we have also seen how to manipulate the path based on the AD value and also, I'm sorry, offset list as well, right? In OSPF planning protocol, we have changed the cost, and we also have a good thing about the path preference, right? That's both the ways, right? We can manipulate the path. But these protocol, if you have a look over there, right? What's the problem with this protocol? If you have a look on the like a RIP, EHRP, OSPF, they have a maximum 2 and 3 ways. The maximum you have 2 and 3 and 4 ways, right? If you have an advanced level of the things. Do you really think that these routing protocols are scalable on the internet side? Because on the internet, what happened, we have a multiple nodes over there. Nodes, we can say that routers, right? So for example, if you want to go from the one side to the another side, right? From router one to router two, you have ISP number one, you have ISP number two, you have ISP number three, you have ISP number four, you have ISP number five. So do you really think that IGPs are scalable to do the path manipulation on the internet side? No, it cannot do that, right? So that's why the BGP has a rich amount of attributes, and based on that attributes, you can manipulate the path. You can simply see that if somebody will ask you, hey, could you please explain me what is BGP attributes? You just say that, hey, BGP attributes is just a extra information, right? It's just a extra information about the route, nothing else. For example, let me tell you, 1.0.0.0, right? For this one, the next hop I'm just considering is the 191.12.1. So this is the one attribute that we have. Another thing, what we can see that by default, if you're going to advertise this route, so the default weight will be what? 32768. That's a default weight for the locally originated route. Then after that, what happen if you're going to advertise this route to the network statement, then what you will see that origin code will be I over there, right? Origin code will be I over there. So basically, what is this? This is called as a, for example, this is the prefix we have, right? This is the next hop information we have. And then we have this is the weight value, right? Again, weight is the Cisco party protocol. This is the origin code we have. So these are called what? These are basically called as a path attributes. So path attributes is just an extra information about the route. So it's depend on the configuration. It's totally depend on the configuration. You will see the different attributes over there. So in a BGP routing protocol, if you're going to use the route reflector, of course, we haven't discussed this part because it's not a part of the syllabus. But in a future, right, for example, when you do the CCI, so you have one of the attributes in a route reflector is called as a originator ID, and another is called as a cluster ID. So these are the attributes that you can see when you're going to deploy the RR over there. So normally these path attributes, right, that you can see that it's totally depend on the configuration. If you have a RR, then you will see the extra attributes. If you don't have a RR, then you will not see the extra attributes over there. It's totally depend on the configuration. And based on these attributes, you can perform the path manipulation as well. Yes, let me look for my some tissues we have. What else? Tissues. That's fine, man. Like I thought, Delhi has some hot, but it's pretty cold in the morning, man. Right? So if you remember that in our BGP, we have seen that weight and local preference that is used to manipulate the outbound traffic, right? Or we can call as an inbound update. Whereas if you're going to use the outbound update, if you're going to manipulate the outbound update, or we can call as an inbound traffic, then you need to use the MED and ACE path. So we have basically seen this thing as well, if you remember that. So weight and local preference are always higher prefer, right? If you see over there, I mentioned this part always. Wait and local preference is always high prefer. But if you have a look for the meta and AS path, it's always lower prefer, right? So these are the major attributes that we are used to manipulate the path. For the incoming update, you can go with the wait and local preference. For the outgoing update, you can go with the meta and AS path. Now, again, which one is the recommendation, right? Like, of course, if you can compare between the wait and local preference, right? Wait, we can say that it's a Cisco proprietary, right? So easily you can compare it. And the local preference is the IEEE standard. So another difference is that if you remember that wait is a local to the router, wait is a local to the router. It means that if I'm gonna configure the wait on the router number 1 as 100, I cannot share this wait information to the router number 2. That's the meaning of local to the router. Okay. Whereas if I'm going to configure the LP as a 200 on the router number 1, right? LP is what? It's not a local to the router. It's local to the AS number. So if a router 1 and router 2 both are belongs to the same AS number, assume that 12, I can save the LP information to the router number 2. That's a 200 over there. That's a difference between the wait and local preference, right? Basic label, of course, right? If you go with the higher level, you will see the another differences as well. And if I talk about the meta NAS path, simply you can see that which one is recommended. So MET is like a metric of the BGP protocol, and AS path is like, remember that AS path is also used to prevent the loop prevention mechanism in the EBGP protocol. At the same time, AS path is also used for the path selection as well. Lower AS path is always preferred, right? Now, what is the major difference? You will see in the CCI part, not because you will not understand over there right now, okay? So let's leave with this part. But again, remember one thing, what people are thinking about the BGP attributes. What's some many person I have seen that what they have a myth about the BGP attributes. They always thinking BGP attributes are always used to manipulate the path. It's a wrong statement. Not all the BGP attributes, right, are used to manipulate the path. If you have a look over there, the AS path information is used to manipulate the path. At the same time, right, at the same time, it is also used for the loop prevention mechanism as well, right? So wait, again, if you see the wait is not used for the loop prevention mechanism, but I can say that wait is used for the path selection mechanism. So each attributes have a different mechanism. When you go in the deep dive, you will understand more about this thing. Okay, so that's all about we have discussed about the BGP attributes, guys. Always remember, we are always manipulating the control plane traffic. So once you manipulate the control plane traffic, or automatically what happened, data plane will be manipulated. If you manipulate the data plane traffic, then you need to go with the policy-based routing at the basic level. At the advanced level, you can see the traffic engineering, or we can say the segment routing that is going to replace the traffic engineering nowadays. Now, that's all about the BGP, guys. So before I'm going to finish the BGP, we have a few topics that's pending. That's called the BGP message type. It's a very simple topic that you guys remember the OSPF protocol. OSPF also message type hello update, right? Hello packet, LSR packet, right? LSU packet, then LS acknowledgement packet, DVD packet. Same like that, if you remember the EIGRP routing protocol, we have a query packet, reply packet, acknowledgement packet, hello packet, update packet. Same like that, we have a BGP message type, or we can call as a packet types as well. The first message type, we have open packet. Now, what open packet is used to do that? It's similar to the hello packet, right? It's similar to the EIGRP and OSPF hello packet, right? It is used to form the neighbor relationship. Right? That's all. If you remember that in the OSPF and EIGRP hello packet, guys, please pay attention over there. In the EIGRP and OSPF hello packet, the hello packet is used for the maintain the neighbor relationship, form the neighbor relationship, right? Form neighbor relationship. At the same time, right, the same hello packet are also used to maintain the neighbor relationship. How? By sending a periodic hello packet. If you go with the EIGR periodic protocol, Rado 1 will keep sending the hello packet at every 5 seconds. If you go with the OSPF periodic protocol, Rado 1 will keep sending the hello packet at every 10 seconds. So maintain the forming the neighbor relationship, at the same time maintain the neighborship. So one hello packet is doing the two tasks, one task and second task. Whereas in the BGP protocol, pay attention guys, open packet is only gonna form the neighbor relationship. It's not gonna maintain the neighbor relationship. Now, to improve the performance of the router, to save the lots of bandwidth of the particular interface, what BGP did, BGP said, okay, let me do one thing. Open packet that's gonna contain the lots of parameter, right? Which is you can say that that's a neighborship parameter, right? And that's really need to form the neighbor relationship. Once the neighbor relationship has formed, do I really need to send all the information? Try to understand in this way. Your OSPF hello packet, right? Okay, forget the OSPF hello packet. Let's make it easy with the EIGRP hello packet. Your EIGRP hello packet, whatever the information that you are sending the router ID, not router ID. You are sending the ACE number. You are sending the hold on time. You are sending the network information, right? Authentication, you are gonna send it. Now you tell me one thing. You have sent the ACE number. You have sent the hold on time. That's a 15 second. You have sent the network statement. That's a 12.0, for example. Authentication, you have sent the CCI over there. So this hello packet that you're using to form the neighbor relationship. And after that, understand the concept. The size of this packet is what? Assume that 90 bytes. Okay, roughly. After that, what you're doing that? After that, you are sending the same packet to maintain the neighbor relationship. Do you really think that do we need this information to maintain this? No, these information are only required to form the neighbor relationship. It doesn't require to maintain the neighbor relationship. So that's why what BGP did, BGP said that, okay, in the open packet, I will put all the parameters that help me to form the neighbor relationship. But to maintain the neighbor relationship, what I can do that, I will send the empty packet. That packet is known as a keep alive packet. Keep alive packet is used to maintain the neighbor relationship. Now you understood, right? It's totally empty packet. So what's the benefit of that one? The benefit is that one is what? Take example, if the open packet size is 90 bytes, right? The keep alive packet is the size is 19 bytes only. So if you see the ratio is what? Ratio is I can save the lots of bandwidth of the router interface. I can save the lots of CPU utilization of the router as well, because I'm sending the less amount of packet size now. Because the keep alive, I have two different packets in the BGP protocol to do the two tasks. But in the EIGRP and OSPF routing protocol, what happened? To do the two tasks, I have one packets only. And that's the biggest disadvantage of the IGP routing protocol. To improve the performance, we have dedicatedly defined the two separate packet types for this guy. The third packet that we can see that over there, right? The keep alive packet that will send at every 60 seconds. That's a hello time, we can call it in a simple language. Hold time is a 1 to 80 second. Slow protocol. The next packet we have, you can see that's a notification packet, as the name suggests that, right? Whenever you have some issues in your router side, then router will notify hey, listen, there is error. For example, router 1 and router 2 we have, right? Understand this is the router 1 and router 2, right? And we have a link between this guy to this guy. I see the router BGP number 1. See the neighbor, take example, okay, 12.2. And I'll say the BGP router ID will be 101.101 right now. Okay. And 12.2 remote AS will be 2 now. Okay. Same thing. What I can do that. Let me write on the IP address on this guy, 12.1, and this is the 12.2. And the IP address, we can see that. Subnet, we have this guy. So on the router number 2, what I can do that. Guys, please pay attention. This is the very important one. As the BGP router ID will be what? 2.2.2.2.2 neighborship. 12.1 and remote AS will be 1. So in that case, what happened? Both the router is going to form the neighbor relationship, right? That's fine. There is no issue. But what happened if I'm going to make this guy, the router ID will be 1.1.1.1. In that case, what happened? Router will generate the notification packet. Hey, one thing, we found a duplicate router ID. We found a duplicate router ID. So in that case, what happened? Router will generate the notification packet. So if you have a duplicate router ID, router will generate the notify the another router. Hey, there's a issues, right? We cannot form the neighborship because of the duplicate router ID. Even forget the duplicate router ID. Even if you have take example, you have a correct router ID, but in between, what happened in the remote AS? If I define the 3 over there, then what happened? When the router 2 will send the open packet, try to understand. In this open packet, what they will do that he will put the hey, remote AS will be 3 right now. What router 1 is configured with the local AS number? It's a 1. In that case, also, what happened? Router will generate the notification packet and he will say that, hey, peer in the wrong AS. Peer in the wrong AS. So any issues, right? If the BGP will detect it, they will generate the notification message to notify there is an error in the configuration. So make sure that your configuration is correct. If your configuration is not correct, they will throw the error message over there. The next and last, that's an easy packet that everyone loves it, update packet. Update packet, it's simply whenever router advertise the route, or if any interface, if any network, not the if any network gone down, then router generate update packet. So either you lose the network or either you advertise it. For example, you have a network 1.0.0.0.0. So in that case, if I put the network statement, take example 1.0.0.0, then what happened? I will generate the update packet. In this update packet, what happened? I will put the 1.0.0 information as an array, right? Network layer utility information. And array is a combination of 2 things, prefix and prefix length. Okay. So this is the normal update packet. In that update packet, what happened? I can put the information of the advertised out, but understand what happened if I lose the network. If I lose the network, again, I'm going to generate the update packet. But in this update packet, what happened? I will put the withdrawn route. Withdrawn route means what? Now you can remove this route from your routing table. So now you will not see the NRI information. Now you will see the withdrawn route information. Withdrawn means what? Remove this route from your routing table. So in the both case, you will see the update packet. So there is only 4 types of packet in the BGP protocol. If you compare with the any IGP protocol like a OSPF and EIGRP, they have a different like a five packets we have. In a EIGRP, depending on the configuration, you will see the multiple types of packet like SI, QD, and SI reply. If you guys remember that, right? But in the BGP, we have totally 4 packets we have. Right? So these four packets are really important. The most important packet is a notification packet. Based on the notification packet, you can easily identify what error you have in your configuration. And based on that error, you can easily identify what missing configuration is there on the router side. I'll tell you one personal, experience, right? 1 minute, guys. Hello. Now, I'll tell you one personal. Let me pause the recording. Guys, apart from the master stuff, we have another things like BGP states we have. Like OSPF protocol, if you guys remember that we have a down state, init state, two-way state, X start, exchange, loading and full. Even let me tell you this thing, EIGRP also has a state. EIGRP has a init, right? Pending and upper state. Three states we have in the EIGRP protocol. Yeah, it's not there in the book, but this is according to the RFC. According to the RFC, we have a three state of the EIGRP routing protocol. You will not see in the book, but it's there in the RFC. Yeah, some of the book you will find this state. Some of the book, not the all one, right? Same like that. In BGP protocol, we have a states over there, right? The first state we have, if I talk about the BGP state, is what? It's the ideal. The meaning of ideal state means what? We are doing nothing. So the BGP has just started, right? But they are not forming the membership, right? So they are not even forming the TCP connection. Then what happened in the, it will go to the connect state. In a connect state, what happened? BGP is trying to form the TCP connection, right? But they could not. Then it will go in the active state. In active state, what happened again? BGP is trying to form the neighborship TCP connection. If the TCP connection is successful, then it will jump into open send state. If connection is successful, then it will jump to the open send state. If connection is unsuccessful, then again it will back to the ideal and connected state. So if the connection is successful, it will jump to the open state, and then it will come to the open send state. In open state state, what they will do that they will router will send the open packet. Once the router 1 will send the open packet, router 2 will receive the open packet and they will respond by sending the open packet. That's called the open confirm state. Now the router will receive the open packet from the neighbor. And now the router responding with own open packet to the router 1, or we can say neighboring router. So normally what happened in our open send state, what happened router 1 and router 2 we have, it will send the open packet. So when he gonna send the open packet, it will move to the open send state, right? When router 2 will receive it, it will say that, hey, I received it, let me confirm it by sending a open confirm packet. It means that I have received the open packet, now I'm sending my own open packet to you. So once the router will receive the open confirm packet, then it will jump to the established state. Established means what? Router has successfully established TCP connection and all the neighborship parameter has matched. right? And now datas are ready to exchange. So in this state, basically we are exchanging all the bits. So if any issue is happening, right? If any issue is happening from the either the established state or open confirmed state, like for anyhow, for any reason, if you get the notification packet, right? The notification packet means what? They will just notify there is an error over there. So if any of the state, you will see the notification packet, immediately what happened, auto will jump to the idle state. And from ideal, he will again try to do the connect and active over there. So basically what happened, these three states are representing that it's a TCP connection. And this three states is going to represent the BGP connection, just to make it easy understanding. So if you see your router is either in the ideal and connect and active state, in that case, what happened? You have a TCP issue. TCP issue means what? Check your reachability. At the NP label, guys, again, wait. At the NP label, check the reachability. Right? And then, right, if your reachability is good, then check the BGP configuration, like you do have any mistakes, like a filtering is applied over the port number, because BGP works on the TCP port number 179. See that is there any block port for the TCP 179? Like someday what happened, like, you can prevent the port number 179 through the ACL, right? Then in that case, they will not form the Navy ship also, right? So that's also good troubleshoot. So if you have any issue with the reachability, check the TCP connection. If you have a configuration issue, check the BGP one. So these are the 6 state of the BGP protocols we have, guys, right? Right. And that's all for the BGP states and packet types. One things that you will learn in the CCI part, that's called as the active and passive. These are the basically a transport connection type. So normally people are not asking in the interview, but yeah, you will see in the CCI part, right? Or when anybody has questions, right? Guys, Gujar is there? No, it's not there, right? So we just told me that he will sharing the any one of the config file that I can explain the configuration to you guys. Okay, not a rush, right? If they will say it to me, I will explain you the any configuration of the any customer configuration. Anyone has the questions in the BGP masses type on the states? Anyone? And I haven't uploaded the notepad file. The reason was like in my laptop, like yeah, like last time, like on the Monday or Tuesday, maybe Monday, I think so, right? So Monday I could not shut down my laptop, and still it was in the sleep mode today, right? So when I open this my laptop, like I could see my older paint file. So I'll upload the notepad file in the drive right now.
Sir,
So
I have
BGP
one doubt, sir.
Yeah, go ahead.
Just go ahead. Sir, I have one doubt, sir. My
Go ahead.
doubt is, sir, uh, suppose, sir, in BGP link is flapping, sir, BGP link flapping.
Okay. This
So
link is
how
public,
can
right?
how can we troubleshoot? And if, sir, hello time keep alive is mismatch, then what is the command to configure, sir?
By the if the link is flapping, so there will be
Yes.
100% the issue with the link flap, right? SFP issues, right? Or you have a QSCP issues, you have a cable bad, right? Cable mistake, right? So anything
Means,
could be
sir,
happening with the bad cable, physical aid issues. So if the link flapping, the physical aid
physical.
issues.
And okay, sir. And
Simple.
if, sir, timer,
Simple, sorry. If your link is flapping, right? 100% there is a physical link. Link flap means what? The interface is going up, down, up, down, up, down.
yes, sir.
Just go with the physical aid. Yeah.
Okay,
So
sir.
what it has got to do with the SFP?
SFP is I forget the full form of this one. A small.
I know SFP very well. I was
What
just
is
asking.
a small port? No, something is what that, right? Small form port factor. Something is full form is there. So SFP is the like where you're gonna insert your cable, right? So if your
Yes,
SFP
no.
is bad,
As I said, I know SFP. You install the fiber cable in it. That's
yeah,
it.
yeah.
So my question was, So I mean, if there's you are saying SFP if if SFP is faulty, or sometimes what happens? I was in a customer side in a data center, so by mistakenly I took out the SFP from the wrong port, although there was no fiber cable on it. But luckily, nothing happened. The customer was about to shout, but luckily nothing happened. So I took. He asked me, "Can you just take the SFP out?" I took out from the wrong port.
Yeah, sometimes see, physically it is right, the hardware issue. So normally even many times happen with me. So I just reset the SFP and it was working fine. Right? So there is some hardware issue will be there, right? Sometimes maybe the SFP is not properly inserted, and maybe the what we call the link not link we can call it uh the terminology, or what we can say that non minute. Come on, what we call it.
Mm.
The frequency, right? The frequency of your SFP and the hardware, right? That support hardware is not matching. In that way, also your link is getting flat. So in that case, just
Right.
reset SFP, it's gonna work it.
Okay, that's fine. So I believe so. We finished the BG because I have a question about the different class.
Yeah, we have done. So Boozer has said
Okay.
that key like they wants to understand one of the BGP country. So if they will have it, just say they say it with me, I'll explain that one.
Okay. So can I ask the question, please?
Now go ahead, man.
Okay. So basically, it was a class number 4. When we did the attributes of the weight, preference, etc. Everything.
Right.
Weight, low preference. I did the lab, but on root router number, I think I have to open the lab maybe. Router number 4,
Uh-huh.
advertise the classless
Route.
IP address, which was 172.16.16.16 and 1. I think I just open it. So basically, and advertise the network, but I couldn't see that network into the router number 1, that which is the other.
Have you applied to the like a next hop self on the R2 and R3?
Okay, hold on.
Check it. If you haven't applied, you will never see that. I'll upload the notepad file over here, man. So you can download from it. BGP.
Sorry, I'm opening the lab. Okay.
Yeah, no issue. And just to let you guys, we have a class on this weekend as well, the Friday, Saturday, and Sunday. Might be we missed on the Sunday because there's a big festival in India, Holi's Holika and something, right? Of course, Monday will be definitely holiday because of the Holi. So but we'll do the class on the we'll try to finish the class on the Friday, Saturday, Sunday, right? Because we missed the class in this weekend too, right? That's why we're coming on the weekend.
Right. So I have got the lab open. So
Okay.
on a router 1,
Uh-huh.
uh, on a router 4, we advertise the classless IP, which is 172, say 16.
Okay. Do you see the
Dot,
route? Check on the router two right now. Do show IPVGP. Do you see the route on the router 2 and router 3?
router 2 and router 3, right?
Yeah.
Okay. Oh, just-
Have you done?
Yeah, just some just it was just taking some time.
So this
I did enter the command show IP BGP, but nothing is coming up
Okay,
on router number 2.
it's showing that out.
No, there's nothing coming up when I enter the command of show IP BGP.
So IPBGP summary, check that command. So IPBGP summary.
Oh, summary. Okay.
No, I'm just saying that. So IPBGP summary. Do you have a neighborship between router 2 and router 4?
Okay, hold on. Yes. So I should give the show IP BGP summary, right?
Right.
I can see the on router number 2, I can see the 192.168.12.1.
But 24.2 is not there, right? 24.4 is not there.
And I can see the 24.4 as well, which is linked towards the router 4.
Do you have a what state is there? It's a 0 prefix, or is there any state mentioned over there?
The state is there's nothing showing up on a state.
It's 0 over there, right? It should be 0 or something.
It's totally blank.
It's a blank, right? So you and now put the command on the router 2, so IPBGP again. Do you see the route now?
Just show IP BGP, that's it. Don't
Yeah,
put
that's
as any
it.
summary.
That's it. No, so IPBGP, that's it.
Okay. So I can see 24.4, next hop 24.4, next hop. Metric is 0.
Now you can see the 172.16.1.0 route.
Sorry, which one?
172.
No, I can't see that now. I can see only the loopback, which is 4.0.0
Okay, I'm
and
gonna
then
make you. I'm
44.
gonna make you host. Just try to share the screen. I'm making you host. Share your screen.
Sorry, what are you gonna do?
I have made you host. Now you can share your screen.
Okay. Just a moment.
कहाँ इसका? Wait. आलिया तूने जूते क्यों फोल्ड किए हुए हैं?
Okay, I'm sharing the screen now.
Yeah, good.
Right.
Okay. Just go on the router 4 now.
मैं बैठ के पढ़ा.
Right.
So run section BGP.
Show run
Type.
pipe, yeah?
Yeah. Just put this, just hit enter. So leave it. Just hit enter. Hit enter. Go down. आराम से ऊपर जाओ थोड़ा सा. Oh, long. Now put the command show route. Show IP route.
Show IP?
Route.
That's a show IP route.
भाई आपने जो नेटवर्क जो डाला है, देखो क्या डाला है आपने लूपबैक 3 पे. आपने क्या डाला है? लूपबैक 3 पे डाला है. देखो सो रन इंटरफेस लूपबैक 3 करो. सो रन इंटरफेस लूपबैक 3.
Show run interface.
इंटरफेस लूपबैक 3. L3 कर दो सीधा. L3 कर दो. 3.
ये तो incomplete command आ गया.
3 डालो. 3. Just put the 3.
Sorry, मैं समझा नहीं. बात कम आ रही है.
Loopback number डालोगे ना. Which loopback number is there? Loopback 3
Oh,
डालो.
loop back number 3. Oh, okay.
देखो आपने क्या कमांड लगा रखा है, ये क्लासलेस थोड़ी नहीं, ये तो आपने क्लास 8 बना दिया, स्लैश 8 बना दिया। यहाँ पे क्या कमांड होना चाहिए था? आप एक काम करो, नो इंटरफेस लूप बैक 3 करो, कॉन्फिग टर्मिनल में जाओ, नो इंटरफेस लूप बैक 3 करो, नो इंटरफेस लूप बैक 3।
नो इंटरफेस लूप बैक 3।
हाँ, अब इंटरफेस लूप बैक 3 फिर से करो। यूज टैब कीवर्ड ऑलवेज, लूप बैक 3 टैब 3,
ठीक
एंटर।
है।
IP एड्रेस 172.16.1.1, 255.255.255.0, एंटर। आपको समझ में आया मिस्टेक आपने कहाँ गया था? आपने स्लैश 8 कर रखा
अच्छा
है।
इसमें, अच्छा मैंने एक और शायद गलती की थी। मैंने यहाँ पर लिख दिया आज सेंटर द मास्क, मास्क लिखना चाहिए था।
आपने मास्क लिख रखा है वहां पे BGP में।
हाँ मैंने लूप बैक में आईपी दिया था 172.16.1.1, उसके बाद मैंने मास्क डन, उसके बाद फिर मैंने ये दिया था सबनेट।
मास्क लिखने की जरूरत नहीं होती है, IP एड्रेस आप कंफिगर करते हो तो मास्क लिखने की जरूरत नहीं होती कभी। वहां पे मास्क
अच्छा
कीवर्ड लिखने की जरूरत नहीं होती है, मतलब यू हैव टू गिव द सबमिट मास्क, बट देयर इज नो नीड टू गिव द मास्क कीवर्ड। नाउ यू कैन चेक ऑन द राउटर 2, आ रहा होगा राउटर।
अच्छा, अब मैं राउटिंग टेबल थोड़ा चेक करता हूँ, जस्ट होल्ड ऑन।
या sure, no rush. Things are you are learning, man. If you're making a mistake, it means that you're doing the practice.
अच्छा अब मैं कहाँ पे जाऊँ,
R2
राउटर
पे
वन पे जाऊँ?
हाँ, राउटर 1 पे चेक कर सकते हो आप, आ जाएगा आप।
अच्छा
Thanks to Dipankar, yeah, you got your lab GNS3. ओपन करो।
हाँ, एक सेकंड एक्चुअली ना।
तो IP BGP आ गया।
आ गया।
एंजॉय मारेंगे।
अच्छा मैंने मिस्टेक यहाँ पे की थी, मैंने रॉन्ग आईपी दे दिया था लूप बैक,
रॉन्ग
राइट?
आईपी दे दिया था, राइट। रॉन्ग आईपी दे दिया था, करेक्ट सबनेट एडवर्टाइज किया था। रॉन्ग आईपी दिया था बट सबनेट करेक्ट एडवर्टाइज किया था, तो मिस्टेक हो गई। कोई नहीं, बट दैट्स अ गुड थिंग, राइट? इफ यू आर डूइंग द मिस्टेक देन यू विल लर्न इट, राइट? आप देखो, आप सेम मिस्टेक आप कभी नहीं करोगे अपनी जिंदगी में दोबारा।
ये यही एक गलती, मैं वो प्रोजेक्ट में गया था तो वो ये वहां पे पूरा रोल बैक हमें करना पड़ गया था इसी वजह से।
No, I understand, man. See, that's what I'm telling you. If you're doing the practice, you will never do the mistake in the war, right? So that's all I always tell the people. If you want to survive in the war, like a war is like a what? Troubleshoot zone, then you need to do the keep practicing, right? If you don't want to survive, lose it, man. Not a big deal. So what people are thinking about the troubleshoot is what, like, okay, man, the BGP, I learned the BGP now. I finished all the video. Now, if I go on the customer call, I can troubleshoot it. No, you cannot do that if you have not practiced. So practice make me perfect. All good?
अच्छा एक सेकंड, मैं यहाँ पे ना सिर्फ मैं रूट चेक करूँ इसको।
तो रहा है, सो आई BGP में। अच्छा, सो IP रूट आप देखो, /24 आ रहा है।
हाँ अच्छा, अब मैं इसके शो आईपी इंटरफेस ब्रीफ चेक करूँ जरा। 1.1 ठीक है, जबरदस्त हो गया।
All good?
चलिए, बहुत शुक्रिया सर, थैंक यू सो मच।
Are no issue, man. Anytime, buddy. Anyone has any
तो
questions, guys? I'm roll backing to my host now again. Reclaim host. Anybody has any questions in the BGP, guys? Anyone has done the practice like the lab? If you haven't, then you will never have a question. If you have, then you must have a question because you cannot understand the BGP in the one shot.
Maskina, I will do this, the whole BGP class repractice again, basically.
Yeah, do that, man. It's very important. Okay. So guys,
Correct.
what I can suggest you now. So I'm done with the BGP now. So I'll catch you tomorrow with the network services, right? Like your HSRP, BRRP protocol. We do that tomorrow. Then you have a NAT and PAT, right? And an NTP and the remaining things as well. We'll do that tomorrow. I'll catch you tomorrow, guys. Okay.
Same time. No worries. Thank you
Okay.
so much.
Thanks, buddy. Thank you so much.
Yes.
I've uploaded the notepad file. You can get the notepad file from the drive, and I'll upload the today videos as well. And
No
just
problem. That's fine.
thank you, guys.
Thanks.
Bye. Have a great day.
Yes.